Hi dear students, welcome to my video class. This is a series of videos I have shared on different topics. I hope you can enjoy the video and it will benefit you. Today, I will discuss one of the important topics from gaseous state. The title of topic is Vander Waals equation of state. Look at here, the kinetic theory of gases. These are the major postulates of kinetic theory of gas. That is, gas molecules are tiny particles. Second, they are in random motion. Their collisions are elastic, no net loss of energy due to the collision. Fourth is laws of classical mechanics followed by the gas molecules follow the Newton's laws of motion. Fifth, I have written in the red ink, the actual volume of gas molecules are negligible as compared to the volume of the container. Actual volume of the gas molecules is negligible as compared to the volume of the container. Sixth is, I written in another link, there is no attractive or repulsive forces between the gas molecule. I will read once again. There is no attractive or repulsive forces between them. And you have learned kinetic theory of gas and an equation based on the kinetic theory of gas. Now, ideal gas equation PV is equal to nRT is based on these postulates. But when we closely watch the properties of real gases, we will observe that the fifth and sixth postulates, I have written in red ink, sixth postulates I have written blue ink, are wrong. What was the fifth postulate? The actual volume of gas molecule is negligible as compared to the total volume of the container. That postulate is wrong. What was the sixth postulate? There is no repulsive or attractive forces between them. Therefore, this equation is not fit for real gases. Hence, we want to modify ideal gas equation so as to fit them for real gases. This modification was done by the scientist Vander Waals. And that new equation is called Vander Waals gas equation, or real gas equation. Let me check the video. Okay, real gas equation. Now, how he modified? How did he correct it? He did two corrections. The first correction is volume correction. Okay. The volume of gas is equal to volume of container. This is our general talk. What is the volume of gas? Volume of the container. Suppose V is the volume of container. We have a container like this. Its volume is V, where containing gas molecules. But this entire V, please carefully listen, this entire V is not available for compression or expansion. And some amount of volume, that is called to B. B is equal to amount of volume blocked by the presence of gas molecules from the compression. What is the statement I have given for B? B is the amount of volume out of the total volume of the container which was blocked by the presence of gas molecules from the compression. This B is called the excluded volume or co-volume. Therefore, V ideal, that is volume available for the compression of gas, is equal to V minus B. What is V? Volume of the container. What is B? Excluded volume. And this much volume is the volume available for compression. Therefore, this is the volume correction. Agree? This is the volume correction. Now, we can do calculation of B. Calculation of B. How do you calculate? You know, in a gaseous system, gas molecules are always in random motion and they are always in collision. Suppose two gas molecules, this gas molecule is collided by this gas molecule. Right? You know, this is the radius of this molecule and this is the radius of this molecule. Both are R, suppose. And this collision can be here, this side or this side or this side or this side. That collision can be probable in every side. Therefore, you know, this much volume, because of these two molecules, colliding molecules, are always non-compressible or blocked from the compression. Once again, this much volume, because of the pair collisions, because gas molecules are always in pair collision, because of the pair collision, this much volume is always blocked. Therefore, we can calculate what is the volume of this molecule, this space, that is nothing but a 2R. Therefore, volume of that space 4 by 3 pi 2R whole cube, that is nothing but 4 by 3 pi R cube into 8. This is the volume blocked by two molecules due to their presence or collisions. Therefore, volume blocked by one molecule is 4 by 3 pi r cube into 4 divided by 2. That is 4 times of volume of a molecule. What is R? R is the radius of a molecule. Therefore, 4 by 3 pi r cube will be volume of single molecule. Now, please careful. B is equal to 4 by 3 pi r cube into 4. This is the volume blocked by one molecule into Avogadro number. This is B. Understand? B is equal to 1 mole into 4 by 3 pi r cube. Right? Therefore, B is 1 mole of volume blocked by 1 mole of gas molecules due to their sheer presence in the container. Fine. Now we can go to next correction. The second correction was pressure correction. Pressure correction, second correction, that is called the pressure correction. Ideal gas equation PV is equal to nRT, where this pressure has been derived based on the assumption that there is no attraction between the gas molecules. But when you take real gaseous system, there is attraction between gas molecules. Because of this attraction, the velocity of the molecule which is going to strike on the walls of container is reduced. Therefore, the pressure will be reduced. Hence, the real pressure experienced by gas molecules in a system will be always lower than its ideal pressure. Therefore, we should have a correction, that is P ideal always greater than P real. Therefore, P ideal should be equal to P real plus a pressure correction. This pressure P is pressure lost due to attraction. Now, calculation of P. How do you calculate? How do you determine? Suppose you have a gaseous system like this, and this is a layer A, and this is layer B. In an actual system, when layer A going to hit on the walls, layer B will pull back. Because of that pulling back, the velocity or force with which they are hitting will be reduced and pressure will be reduced. Okay, therefore this P, pressure lost, directly proportional to concentration of gaseous molecule in layer A and concentration of gaseous molecule in layer B. Therefore, P is equal to n square by directly proportional to n square by v square, or P is equal to a n square by v square. A is a proportionality constant or a Vander Waals constant. Therefore, we can write the modified ideal gas equation or real gas equation. real gas equation. Real gas equation nothing but it's a modified form of ideal gas equation. Our ideal gas equation is PV is equal to nRT. Instead of P, now we will use P plus A n square by V square. Instead of V, we will use V minus NP is equal to nRT. For one mole, n is equal to 1, P plus n square by V square, V minus B is equal to RT. Okay. I hope you have understood this video. Now I put a challenging question for your thinking. Many students used to ask me why B has been subtracted, n square V square has been added. Please remember, this B is real, this V is real, this is ideal, this is ideal. This is now the ideal pressure, this is now the ideal volume, this is a real volume, this is a real pressure. You please think about it. I put that question for your challenge. Thank you for watching. Have a nice day.